Hello everyone, myself Vanita MH. I am working as a lecturer in Government Polytechnic Airpet. I heartily welcome you all for this session. In this session, I am going to speak about an ARM controller Unit 2, that is Session 3, ARM instruction set. In Session 1 and Session 2, we learnt about the basics of ARM instruction set. In a last session, that is in Session 2, we learnt about the block diagram of the barrel shifter and also its operations. Then we also learnt about the different shifting operations performed with this barrel shifter. I want to recall some points, dear students. You know, in ARM controller, we don't have shifting instruction. There is no shift instructions, particularly in ARM controller. To do these shifting operations, we have to go for a mechanism called a barrel shifter. This barrel shifter is mainly used to shift one of the data left or right before applying into an ALU. Then this barrel shifter is mainly used to increase the power as well as the flexibility of a ARM controller. Then this barrel shifter in our ARM processor will be used to perform the different shifting operations, that is 5 different shifting operations, namely logical shift left, logical shift right, arithmetic shift right, rotate right and rotate right extended. In our last session, you learned all these things, what do you mean by logical shift left, and you learned how to implement that one with an example. Now we will move on to the next session. That is, in this session, you are going to learn or understand the different classification of ARM instruction set. In the last classes, you learned what do you mean by ARM instruction set, what are all instructions are there you learned. In this class, you are going to learn the different classification of ARM instruction set, and also you can learn about the classification of data processing instructions, and also you will be able to understand what do you mean by data processing instruction. In that, you can illustrate easily the two instruction, that is MOV, move instruction, and MNV, that is move negative instruction, with an example and with its syntax. First, we will see what do you mean by this ARM instruction set. Instruction means you are giving some commands to a processor to do some task, that is called instruction. ARM instructions process data held in registers. You know, we can't manipulate data within a memory. I told you in a session 1. We don't have any data processing instructions to manipulate the data found in memory. So that we have to take the data from the memory into the register. From the register, you can manipulate or you can change the data as you want. So our ARM instruction process data held in registers and only access memory with load and store architecture. You know this one. The ARM won't the ARM uses the load and store architecture mainly to manipulate data within the memory. So load and store means before getting the data from the memory, you have to store that data into the memory. So putting the data into the memory is called storing. Fetching the data from the memory is called loading. So load and store instructions are used to perform the or to access the information from the memory. Then our ARM instructions commonly take 2 or 3 operands. In the last class, I told you the ARM addresses are all ARM instructions are all 3 data address. It means it is containing 3 operands or 2 operands. Here, consider the example, that is add R3, R1, R2. This is nothing but 3 operand instruction. Okay, 3 operands means you are using 3 registers R3, R1 and R2, and you are giving an instruction called ADD to the ARM processor to perform the addition operation. Here R1 and R2 are called as the source registers and R3 is called as a destination register. This instruction will perform an addition of R1 and R2, and whatever results you will get, that will be stored in a destination register R3. This is 3 address operand instruction. Next, we will move on to the classification of ARM instructions. Mainly our ARM instructions are classified into following types. The first will be the data processing instructions. The next will be the branch instructions, load and store instructions, software interrupt instructions, and program status register instructions. What do you mean by data processing instructions means? These are the instructions which are mainly used to manipulate the data found in the register. That is, you are changing the data. That's why it's called a data processing instructions. Then the branch instructions. What do you mean by branch instructions? This is nothing but these instructions are used to call a subroutine, or you are going to branch to a next instruction means you have to use this branch instruction. Mainly for the subroutine you are going to use this branch instruction. Then load and store instructions. These load and store instructions are used to fetch the data from the memory or putting the data into the memory. In the last class you saw in load and store instructions you will be having three different types, that is single data register transfer, that is LDR and STR, multiple data register transfer, that is LDM and STM, and the swap instruction, that is SWP. These instructions are all used to access the data from the memory before manipulation. Then the software interrupt instruction. This software interrupt instruction is mainly used to call an interruption. The software interruption is mainly called by using this instruction. Then program status register instruction. You know, in our ARM we will be having a program status register that will contain a flag register. So this program status register is mainly classified into two types, that is current program status register, that is CPSR. The secondly, the saved program status register, SPSR. So we don't have any instruction to fetch the data found in CPSR or SPSR directly. For that we are going to use this program status register instructions to fetch the data from the register and moving the data into the CPSR or SPSR. So the program status register instructions are mainly MRS and MSR. The MRS is mainly used to copy the content of a register into an CPSR or SPSR, and MSR is used to copy the content of the register into the CPSR or SPSR, and MRS is mainly used to copy the content of a register to the content of the SPSR or CPSR to the registers. These are the main classifications that we found in a ARM processor. Now we will move on to the data processing instruction. The first instruction, that is data processing instruction. The data processing instructions mainly used to manipulate data within the registers. So these data processing instructions are mainly used to manipulate the data. Before manipulation of the data, we have to fetch the data from the memory. For fetching the data, to fetch the data from the memory, you have to go for this load and store instructions. The commonly used data processing instructions in ARM are move instructions, arithmetic instructions, logical instructions, comparison instructions, and multiply instructions. The first one will be the move instructions. Move instructions means you are moving the content of a one register to the another register, or this is mainly used to initialize the values. It is mainly used to initialize the value. That is, the move instructions are basically used to give some constant value or initializing the value before the manipulation. For that we are using the move instruction. Arithmetic instructions means the arithmetic instructions will be containing the addition and subtraction of the 32-bit signed or unsigned numbers. In this you are going to perform an addition as well as the subtraction of two 32-bit data. Then logical instructions. The logical instructions are mainly used to perform the bitwise logical operation between the two datas, that is two 32-bit datas will be bitwise logically operated, that is logical instructions. Comparison instruction means these instructions are used to compare or test a register content with given single 32-bit value. It is compared with that value, whether it is equal or not equal, that will be done by this comparison instruction. Then multiply instructions are used to multiply two 32-bit values by using a MAC, multiple and accumulate unit. Using that MAC unit, you will be performing this multiply instructions. Now we will see how this data processing instructions will be performed. Most data processing instructions can process one of their operands using the barrel shifter. You know, before while explaining the barrel shifter, I told you before applying any data to the ALU, one data should be no pre-processing and another data should be pre-processing. It means one of the data will be applied directly, but another data will be applied after applying into the barrel shifter. So one of the data will be applied to the barrel shifter. That barrel shifter will perform the right shift or left shift, whatever you want, for the fixed amount of that you are specifying. After that, the result, whatever result you get from the barrel shifter, that will be applied for an ALU. Then that ALU will perform the all data processing instructions. You keep in mind, in a data processing instruction, one of the data will be applied directly to the ALU and another data will be applied to the barrel shifter. After the barrel shifter operation, the result will be applied to an ALU. Then in data processing instructions, we are using a suffix s. What do you mean by this s? This suffix s is mainly used to update the flags in the CPSR. In CPSR, you know, we have different flags like negative flag, zero flag, overflow flag, carry flag. That like that you will be having the flags. To update that flags, you have to append a suffix called n in an instruction. The move and logical instructions update the carry flag C, negative flag N and zero flag Z. You consider this example. In this example, you leave this S, okay? You leave this S. First, we will see ADD R0, R1, R2. What it will do? Add R0, R1, R2 means the contents of the register R1 and the contents of the register R2 are added and the result will be stored in R0. But you imagine that there is no S. If there is no S means after the addition, if the carry is set or if you got the result as 0, it is not updated in a CPSR. It means it won't update the CPSR flag. But when you put the suffix s in instruction, it means if you add the suffix s here, it will perform the same operation. It will perform the same operation R1. R0, R1, R2 means it will perform the addition of R1 and R2 and the result will be stored in R0. And also it will do whether and it will update the flags also. Flags also means whether if the after the addition if you got any carry means the carry will be set and if the result is 0 then 0 flag will be set like that. After the addition operation what are all flags will be set or it means by putting the suffixes you can update the flags in the CPSR. So, to update the flags in the CPSR, you have to put a suffix s in the instruction. Okay. So, the next will be the first data processing instruction will be the move instruction. That is MOVE, move instruction. The move is the simplest ARM instruction that copies immediate value N into a destination register RD, where N is a register or immediate value. It means to copy the value from one register to the another register, you will be going to use this move instruction. Just you are copying the content of one register to the another register. It can be a register or it can be an immediate value. This instruction is useful for setting the initial values and transferring the data between the two registers. Okay. Now we will see the syntax. Syntax is the instruction move is nothing but MOV. Then you are putting some condition and also you are giving the suffix s. Suffix s means be careful. If you put the suffix s, it will update the flags in the CPSR. If you won't put s means it won't update the CPSR flag. If you want the updation in a flag means, if you want to update the flags in CPSR, then you have to put suffix s with the instruction. So this instruction move s rd comma rn means the content, the immediate value n will be moved to the destination register rd. The move instruction, in our ARM we will be having two types of move instruction, that is MOV and MVN. MVN means move negative. MOV means move a 32-bit value into the register. That means the destination register RD is nothing but N. It means you are directly moving the same content into the another register. What do you mean by MVN means move the not of the 32-bit value into the register. What do you mean by not? Not is nothing but a complement. Complement means 0 will become 1 and 1 will become 0. So the content, whatever content you are giving, that will be complemented, and the complemented value will be moved to the register, destination register RD. That's why the RD is nothing but the complement of N. So the two instructions, move instructions in our ARM is MOV move and MVN, that is move negative. Now we will see some of the formats and examples with respect to the move instruction. In first one, consider this format, move Rn comma immediate value n. What do you mean by this? This is nothing but it copies an immediate value n into the register Rn, that is destination register Rn. I will take one example. Example is move R3 comma immediate 50. What do you mean by this? Here the immediate value is 50. That immediate value will be moved to the destination register RD. So after the execution of this instruction, the content of register R3 is nothing but 50. The next format is move Rn comma Rm. It means here you are moving the content of one register to the another register. So Rm is the source register, Rn is the destination register. You are moving the content of a source register Rm into the content of a destination register Rn. Okay. Now we will consider one example. Move R3 comma R4. Now that we will see here. What do you mean by move R3 comma R4? It means the content of register R4 will be copied into the content of register R3. Whatever content is there in a previous in register R3, that will be erased. After the execution of this instruction, the new data will be saved in a register R3. Okay. Now you consider here R4 is equal to 05 and R3 is equal to 08. Now the instruction is move R3 comma R4. Move R3 comma R4 means the content of R4 is 05, that will be moved to the R3. It means the content of R4 is not changed, but the content of R3 after this execution, after the execution of this instruction will be 05. Consider one more example here. Here I took R5 is equal to 02 and R7 is equal to 03. Then I put one instruction here, move R7 comma R5 comma LSL immediate 2. Dear students, what do you mean by LSL? LSL is nothing but logical shift left. So move instruction means it is not only moving the contents of a register directly. We can do a logical shift left, any operations. The shifting operations we can do for one of the data, and we can move that one easily to the another register. That one only we are doing here. You have to take the content of register R5. Then you have to shift that content of register R5 by logical shift left by 2 times, and whatever data you get after the logical shift left, that will be moved to the destination register R7. So here R5 is nothing but 02. It means 00000010. After the logical shift left by 2 times, you will get 00001000. It means 08. Okay. That 08 is the content that is moved to the register R7. So see here R5 is 2 only. It won't change. It is same as the previous one, but the content of register R7 is changed. That is, now it became 08. Okay, now we will see MVN instruction. MVN stands for move negative. Negative means it's a complement. Complement means The zeros will become 1 and ones will become 0. It is the simplest ARM instruction that copies the complement content of n into the destination register RD, where n is a register or an immediate value. See the syntax. The syntax is nothing but MVN. You are putting some condition with a suffix s, RD, comma n. Putting suffix s means it is updates the flags found in CPSR. You will be having some content in n. But in move instruction, you are not doing any complementation. I mean, you are not taking any negation value. Whatever value is there in n, that will be directly moved to the RD. But in MVN instruction, whatever data is found in n, that will be complemented. After the complementation, the result will be stored in destination register RD. So we will see some formats found in a move negative instruction. This is the first example, MVN Rn comma immediate n. It means the immediate value n will be taken and it will be complemented. After the complementation of the value n, the negated value will be moved to the destination register Rn. You consider here MVN R3 comma immediate 50. It means first you have to take 50 value. 50 means 0101 0000. The move instruction directly moves that content to the R3. But here you are doing MVN. MVN means you have to take that value, you have to negate that value. After the negation, you will get it as 1010 1111, that is AF. After the execution of this instruction, the answer will be AF. That AF will be moved to the destination register R3. This is move negative. Here consider one more example, MVN Rn comma Rm. What do you mean by Rn comma Rm? Here you are moving a content of a register to the another register. Before moving to the content of a register to the another, you are complementing. That is MVN means you have to complement and you have to move the content to the next one. In this example, I took R5 is equal to 0.5 and R7 is equal to 0.8. MVN R7 comma R5. What do you mean by this? The R7 is nothing but complement of R5. The R5 is equal to 0.5, that is 0000 So the complement of this answer will be 1111 So the answer is FA. That FA will be stored in a destination register R7. Okay, now consider one more example. Here I took R5 is equal to 0.2 and R7 is equal to 0.3. Now MVN R7 comma R5 comma LSL immediate 2. So you leave this one. You see here whether there is any shifting operation is there in a source register. Yes, there is some shifting operation, that is you have to shift left by 2 times. Logically shift left the content of R5 by 2 times. Now I will take the content of register, that is 02. That is 0000 That is logically shifted by 2 times. After the logical shifting of the shifting of this content, we will get 0000 But after this, you can't move that directly to the R7 because here the instruction is MVN. MVN means you have to complement the content and then you have to move it. Then R7 is nothing but the complement of this value. Complement of this value means it will be 11110111. So the answer will be F7. So after the execution of this instruction, the F7 will be moved into the register R7. So my dear students, keep in mind the simple move instruction means whatever content is there in a source register, that will be directly moved into the destination without any manipulation. But in MVN instruction, before moving the content of the source register into the destination, you have to do the ones complementation, or you have to complement the content, that is you have to convert zeros to 1 and ones to zeros. Then afterwards you have to move the content into the destination register. Okay, now we will see what are all questions they may ask in an exam with respect to this session 3. The first question will be list the data processing instructions with one example each. You have to list it. So listing means the data processing instructions will be classified into move instructions, arithmetic instructions, logical instructions, compare instructions and multiply instructions. First you list that one and you give one example for each. List the classification of ARM instruction set. Mainly our ARM instruction will be classified into different types like data processing instructions, program status register instructions, software interrupt instructions, then branch instructions, then load and store instructions. You have to list the classification of ARM instruction set. Then the third question they can ask means explain move and MVN instructions with example. The students, you write a move, what do you mean by move, why it is used and its syntax with one example. Similarly for MVN means move negative and write its syntax and give one example for each. Okay. Now we will see some multiple choice questions they may ask from this session. The first question will be ARM process data held in dash. ARM always stores the data in register. Whatever it is going to process the data, that will be fetched from the memory and then it will be put in a register. After that only it will manipulate the data. That's why the answer is C, that is registers. Next one, MVN stands for. MVN means N means negative, that is move negative. And the answer is B. The next one, dash instruction is used to get one's complement of the operand. One's complement means the move instruction won't get any complement. That is MOV instruction won't do any complementation. But MVN instruction will do the complement of an operand. So the dash instruction means that is B. That is MVN instruction will do the one's complement of the operand. The next one, instruction in ARM machines is encoded into dash words. Dear students, I told you the ARM is a 32-bit processor, right? The instructions or registers, whatever is there, it is also a 32-bit. 32-bit means it can be divided into 4 bytes. You know, 4 into 8 means 32. So the answer is 4 bytes. That is answer B. The next one, ARM processors were basically designed for dash. This is the one of the applications, the main application of the ARM processor is it is mainly used for mobile systems. The answer is mobile system. The mobile systems are all having this ARM processor for its clarity and all. So the answer is C, that is mobile system. The next one, ARM processors don't support byte addressability. You have to tell whether the statement is true or false. Dear students, ARM processor always supports byte addressability. It means whatever the statement they given, it is false. It is false. The ARM processor supports byte addressability. You keep in mind it is a byte addressability. So the answer is false. The true statement is the ARM processor supports byte addressability. The next one, in the ARM, PC implemented using dash. What do you mean by PC? It's a program counter. Program counter means it is a register where the address of the next instruction will be saved. I mean the address of the next instruction is saved in a program counter. So it is nothing but a register. So the answer is general purpose register. General purpose register. The next one, using S suffix on a data processing instruction updates the flags in the CPSR. You have to tell whether the given statement is true or false. It is true. If you won't put the suffix S in an instruction means it won't update the flags in a CPSR. If you want to update the flags in the CPSR, then in an instruction you have to put a suffix, capital suffix S, that will indicate it is mainly used to update the flags in the CPSR. So the given statement is true. Now we will see one example. Let R3 is equal to 2 and R4 is equal to 5. The contents of register R3 and R4 after the execution of instruction move R3, R4 is dash and dash. You see here the content of R3 is 2. It's a destination register and the content of R4 is 5. It's a source register. The move instruction means the content of the source register will be moved to the destination. It means the 5 will be moved into the R3. So the R3 content is 5, but the source register the content won't change. It is also 5. So the answer is B, 5 and 5. Okay, next, let R3 is equal to 2 and R4 is equal to 5. The content of register R3 and R4 after the execution of the instruction MVN R3, R4 is dash and dash respectively. My dear students, here we are using move negative instruction. Okay, the R3 is the destination and R4 is a source. Source is the value given for the source register is 5. 5 means 0101, right? 0101, you can't move that directly into the destination because it's a move negative. So 0101 means it is 1010. The ones complementation of that value is 1010. 1010 means it is A. So the content of R3 is A. Okay, first is A, but the content of R4 it is won't change. It is always 5 only, right? So the answer is B, A and 5. I think you understood clearly, dear students. Okay. Now I will tell you the some textbooks, what are all I referred to prepare this PPT and all. These textbooks are prescribed textbooks that is given in your ARM controller syllabus. The first one will be the ARM System Developer Guide, that is Andrew Enslaw's, and next will be the ARM Assembly Language, that is William Hall. These textbooks will be a very good one. When you get time, no, you go and read this one so that you can enhance your knowledge. In ARM System Developer Guide, for this move instructions and arithmetic instructions, they clearly mentioned syntax and also example. The solved examples are given in this textbook. You go through the textbook and solve. You also solve the example so that you can clearly understand how these instructions will be performing. How these our ARM is performing all these data processing instructions, everything instructions and how it is performing. It is clearly mentioned in this textbook. Please go through this. Okay, finally, I would like to thank the Shant Kumar Nayak sir and Rangashamaya sir for giving me an opportunity in session 3 to speak about ARM instruction set, and also I thank DTE for selecting me as a content developer for this ARM controller. Okay, my dear students, go through this session and read textbook carefully and solve. Don't take this subject as a theory subject. It is a problematic subject. You read once and write properly and solve as many examples as possible so that you can't forget anything. The instructions and all, it's a fixed one. You have to write it as it is. You can't imagine and write in this subject. So go through the instructions carefully, do well, study well, and take care of about your health. All the best, my dear students. Thank you.